Hi there, this is Ms. Page. In this lesson, we are going to go over some examples of finding the surface area of cylinders, and we are going to talk about how to do so using a formula and also how to do so using a net. So a couple of pieces of prior knowledge that we are going to need to use is one, finding the area of a circle, because in surface area we need area of the bases, and the bases of a cylinder are congruent circles. So area of a circle, remember, is pi r squared, where r represents the radius of the circle. And another piece of prior knowledge that we're going to need is circumference of the circle. Circumference, remember, is a word that we use to describe the perimeter of a circle, usually basically because it is around. Where polygons like rectangles and triangles have straight sides, we call that perimeter. When we switch to the curved circle, we call its perimeter circumference. And 2 pi r is a formula for finding circumference. An alternate formula is not 2, pi times diameter, because diameter is 2 times r. And so you can use either one depending on what piece of information you originally have. Remember though that we do need r for area of a circle. So sometimes it's just better to stick with using r so you don't accidentally get the numbers mixed up. So we take pi times the radius and then double that times 2. And that gives us a circumference, which notice is a linear measurement, measures the outside edge. Like if I cut the circle and laid it out flat, it would give me a line segment, and that is the length of that line segment. All right, surface area of a cylinder. So we use S to represent surface area in these particular formulas, and if we're finding the entire surface area, we would use the entire surface area formula. So here it is in general. Notice it's got that L in it, like we saw with our prism's surface area formula. L stands for lateral area. Lateral area, the word lateral refers to side area, but in a cylinder, there's technically only one side of a cylinder, and it is curved. So it's kind of interesting here. This is actually what we're looking at when we find the area of that curved side of a cylinder, because if you remember from our first lesson when we talked about nets, the net of a cylinder gives us 2 circles for our 2 bases and a rectangle when we fold out the side and lay it down flat. Because the rectangle is wrapped around the edge of a circle, when that's unfolded, that becomes this line right here, and that measurement is, notice, the circumference of the circle, so it is 2 pi r. And this measurement right here, which is the height of our cylinder, is the other measurement of that rectangle that we get. So that 2 pi r h is length and width, so this is like length, this is width of that rectangle. And then we have, remember, the 2 circles. Area of each circle is pi r squared, so 2 times base area becomes 2 times pi r squared. All right, here is our first example. So all surfaces of a trash can, which is in the shape of a right cylinder, including the lid, just in case we were wondering, are going to be painted. And it's here talking about outside surfaces. So unless it specifies otherwise, we're always talking about the outside surfaces. So we're simply to find the area that's going to be painted and do so in square feet. Notice here it says we should round to the nearest tenth. Sometimes it might ask for an answer in terms of pi, but here we're going to take and use our calculators and get an answer to the nearest tenth. So if we want our area to be in square feet, we need all of our measurements to be in feet. So 15 inches, we're going to have to convert. So we're going to take that, first thing we're going to do is take that 15 inches, multiply it times our conversion ratio to turn it into feet. We know that 1 foot is equivalent to 12 inches. So our inches cancel. So now we're going to take 15 divided by 12, and that will give us our feet measurement. Here we get 1.25. We do not want to round that to 1.3. That would throw everything off. So we're not going to use that. We're going to use 1.25. All right. So now, next, we're going to look at the formula, if we're going to do it using a formula. So again, for this problem, I'll do it using a formula, and then also using the net idea, where we kind of are more visual that way than algebraic. So our surface area S would be our lateral area, our side, plus 2 times our base area, which are the circles. So remember that lateral area is a rectangle. Area of a rectangle is length times width. The thing is, the length of this rectangle, or you could think of it as the width, whichever you prefer, is the circumference of the circle. And circumference is calculated as 2 pi r. And then the other measurement is the height of the cylinder, of the rectangle, plus 2 times base area, which again is the circle. So area of a circle is pi r squared. So the 2 measurements that we need for this are radius and height. So our 2 feet is our height because it goes from base to base, circle to circle. So that's our h measurement. Our radius, here's where, and we've talked about this in our volume unit, but let's go over it again, interpreting diagrams correctly. So we have this arrow here for our 15 inches, which we converted to 1.25 feet. And one of the things you have to realize, no matter where an arrow is pointing, it is always indicating the length of the entire line segment in the diagram. And this line segment goes all the way across the middle of our circle, which really means that this 1.25 feet is our diameter, not our radius. And so we have to calculate our radius. So over here, I am going to figure out my radius, which remember is half of my diameter. So I take my diameter divided by 2, and that is going to give me my radius. So 1.25 divided by 2, and this is going to give us 0.625. The units on this will be feet, because our diameter is in feet, so is our radius. That's our radius r. So now I'm just going to plug in my numbers here. So I have 2 times pi times my radius of 0.625 feet times my height of 2 feet. Notice that's going to give me feet times feet for square feet, plus 2 times pi and my radius of 0.625 feet squared. So remember, here we're squaring the 0.625 and the feet. So that gives us square feet also, which is what we should expect here. So, all right. Now, personally, I would recommend that you just use your calculator to do the entire calculation. You don't really need parentheses because you want the multiplication to be done before the addition, and it will be. That is the definition or natural order of operations. So I just put in my calculator 2 times pi times 0.625 times 2 plus 2 times pi times 0.625. Hit the squared key and then hit equals, and then we're going to round. So let's change this to an approximation symbol. All right, let's try the calculation. All right, and if you are doing the calculation along with me, hopefully you came up with 10.3 square feet. And now we can write our conclusion. So for our conclusion, again, we were looking at the area to be painted of a trash can. So the area of the trash can that will be painted is, this time for accuracy, we're going to say about, because we did approximate this to the nearest tenth. So about 10.3 square feet. All right, so before we go on to the next problem, again, I just wanted to show you how to do this particular problem using a net instead of the formula. You might like that better. You might find it easier to remember. So it's always good to have options. So one of the things we have to remember is what the net is of a cylinder. So like I said, cylinders have two circles. So we've got two circles and then one rectangle for the side. And we have to remember how to calculate the area of each of those in this situation. Circles, you just have to remember the area of a circle, pi r squared. And then for the rectangle, though, more specifically than length times width, you have to remember how that length, or if you call it the width, that's fine too, is calculated, which is the circumference of the circular base. And circumference, C, is 2 pi r. So you get 2 pi r, and then the width or length, if you're flip-flopping them, either way, the other measurement is the height of the cylinder. And then you plug in your numbers and add everything together, and that will give you that same to the nearest tenth, 10.3 square feet. All right, let's take a look at the next problem. So here it says an aluminum can is a right cylinder with the given dimensions. It says the label is going to be wrapped around the entire side of the cylinder. We're to find the amount of paper needed for the can's label. This is a little different. Find the amount of paper needed for the can's label. So reading is very important here. Again, underlining, highlighting, always good, like I model with you guys in the examples. And we know that this label is only going to be wrapped around the side of the cylinder, which means that we do not want to include the area of our circular bases this time. So really, mathematically speaking, what we are finding the area of is just the lateral area, the side area. So we have to remember that that side area is a rectangle, an area of a rectangle, length times width. Here for a cylinder is circumference of the circle, 2 pi r, times the height of the cylinder. So that is what we're calculating. So we still need radius and height. And here, did it say what we wanted? Nope. So it doesn't specify units. Notice that both of our units are already in centimeters. They match. So it's best just to go with centimeters and have it be in square centimeters. Here, notice that this arrow, the segment it's pointing to, goes from the center of the circle to the edge or circumference only, which means that by definition, this is our radius r. And our 9 centimeters would be our height because it goes from circle to circle, base to base. So this would be our h. So in this problem, it's kind of nice and straightforward. We don't really have to do any conversions or other calculations. So our surface area is going to be 2 times pi times our radius of 3 centimeters times our height of 9 centimeters. Centimeters times centimeters is going to give us centimeters squared. We're going to round to the nearest tenth again. So I'm going to use my calculator here again. Again, I just type that in. I don't need any parentheses here because it's all multiplication. So let's try that calculation. So here, hopefully you're coming up with the same thing I am. I get 169.6 centimeters squared, or square centimeters. So now all that's left is for me to explain what this means in terms of the context, the situation. So I am finding the amount of paper needed for the can's label. So actually, I think I'm going to reword this one again. I am going to say, since this is approximated, about 169.6 square centimeters of paper is needed for the can's label. All right, let's move on to what's next. Here we have a practice problem. So I would recommend you pause the video here, give this problem a try, then come back when you're ready to check your answer. Let's take a look at the answer to this practice problem now. All right, hopefully you came up with about 206.1 square inches. So here the problem told us that we needed square inches. We wanted total square inches. That means for the entire cylinder. And it's needed to make an aluminum can. That's our context here. So we had to convert our 1.2 feet into inches, which gave us 14.4 inches. And we had to understand that this is shown using the formula again, 2 pi r h for the side and 2 pi r squared for the two circle bases. The 2 inches would be our radius because the measurement of the line segment goes from the center to the circumference. And the 14.4 is our height because it goes from circle to circle. So 2 pi radius height plus 2 pi radius squared. And then rounded to the nearest tenth, that's our 206.1. All right, let's take a look at what's next. Another practice problem for you to try. Pause the video here, please. All right, let's take a look at the answer to this practice problem. So hopefully you came up with about 31.4 square inches. And this one you didn't have to do any conversions. Everything's given in inches, and we want square inches for the area of the paper. So, but here you did have to realize that the 5 inches is a line segment that goes all the way across. So the 5 inches is your diameter. So you do have to find radius by taking the diameter and dividing by 2. So 2.5 inches is your radius. And here, oh, I was a little mistaken, I think. We do want, so the side of a candle is going to be wrapped with decorative paper. So we only want our lateral area here. So I better read more carefully. So lateral area is just the side, which is the side that's a rectangle, where its length is circumference of the circle, 2 pi r, and its width is height of the cylinder. So 2 inches is our height, and 2 pi r would be, make sure we use 2.5, not our 5 diameter. So we have 2 times pi times 2.5 for our radius, and our height 2 inches, and that's what's giving us this approximate 31.4. All right, next. So we have reached our closure. So one of the things when you're doing not just cylinder problems, this can apply to prism problems and other types of solids we have yet to talk about. So make sure that you understand in any situation the difference between finding the surface area, which is the entire surface area, versus what's referred to as the lateral area of a cylinder. Think about that. All right, you ready? Here we go. Let's take a look at what we should be saying. So when you are finding the surface area of a cylinder, you have to make sure that you find the area of both circles or bases and the side. And here it uses the formula. You could also, of course, use a net. That would be fine also. But the key thing is making sure you understand that you're doing both circles and the rectangular side. If you're only finding the lateral area, that means it's just the area of the side, which is just the rectangle, and that is then just 2 pi r h, or which is capital L for lateral area. All right, that finishes up this lesson. Have a great day.